Hey there, everybody. It's Miss Wilson. We are going to be dividing with decimal divisors. Now, this is brand new for sixth grade and brand new to you. So we need to really pay attention. So during this lesson, I really want you to get out that journal and write notes. So whatever I have on the screen, I want you to have on your paper because that's going to be a submission for you when you submit for a grade as evidence of learning. I want you to take a picture of your notes and you're going to submit that as a photograph attachment. Okay, so get out your notebook, pencil and paper, whatever you need, colored pencils. Make sure that you take good notes, okay? So pause this video, go grab your things, and come on back. Okay, so now that you have your pencil and paper, something to write with, and some great notes are about to happen, let's get started. Okay, so in our other previous grades, we learned that we can divide decimal numbers by whole numbers, and whole numbers by whole numbers, of course. We can also divide decimal numbers by decimal numbers, okay? Decimal dividends with decimal divisors. Okay, so if we think about fractions and division being the same, let's just talk about fractions in general, equivalent fractions, okay? Fractions and division are the same. We can talk about fractions and it can relate to division, right? Okay, so if we have 1/10, but we need to have a fraction, for whatever reason, we need to have an equivalent fraction with hundredths. Well, what we can do with fractions, making equivalent fractions, we can just add a 0 on top and a 0 on bottom, and look what happens. Okay, so let's think about that in terms of money. Okay, so if we have 1/10 of a dollar, right? If we have 1/10 of a dollar, let's think of that as a decimal. Oh my goodness gracious, why do I keep thinking about fourths? Good Lord. Okay, if I have 1/10 of a dollar, that's 0.1, right? Well, don't we know that that's also the same as 10 hundredths? So this is 1 dime if we think about values, and this is equal to 10 pennies. Aren't they both worth 10 cents? Yes. Okay, so you might think, what on earth does this have to do with dividing with decimal divisors? Well, what did we do here? Let's think about moving a decimal. If you have a number like 10, okay, I'm going to write it big over here, and then I want to increase the value, I just move that decimal over. I've multiplied by 10. I move the decimal over. Okay, we can write any whole number. That kind of looks like a smile. We can move that decimal over 1 time, and that means it's 10 times the value. Well, what did we do here? We also moved that decimal over. If we have 1, we can move the decimal over, and we've made a number that's 10 times that value, and we've made it 10. So both of these still have the same relationship. Okay, so 1/10 has the same ratio. You're going to learn about ratios later, but 1/10 has the same value as 10 hundredths. It's an equivalent fraction. Okay, so what we do is we say, okay, let's just move the decimal over in the numerator, move the decimal over in the denominator. Okay, let's try another one and see if this makes a little sense. Okay, let me erase all this stuff. All right, let's do an improper fraction. It can work the same way. Okay, what if we have 45 and we have fifths? For whatever reason, we need to make this times 10. Okay, if you multiply the numerator times 10 and the denominator times 10, multiplying the same number by the numerator and denominator of a fraction gives you an equivalent fraction. And we've talked a lot about that, right? Okay, so if we look over here, if we did that, any number times 1 will give you that same number. So if we multiplied times 10 with both, that means we just multiplied by 1. These have equivalent value, right? Well, if I do the same thing with any other fraction, then I'll get an equivalent value. The 450 50ths has the exact same relationship or value as 45 fifths. How on earth does this relate to division? Well, let's see. Let's write this as a division problem. 45 divided by 5. Okay, that was the original problem right here. Well, we know that 45 divided by 5 is 9. Well, what we did here was we moved the decimal over, and let's see if 450 divided by, oh, that's cool, it turned it into a rectangle, hang on. 450 divided by 50, let's see if that equals 9. If that's true, then we have the exact same relationship. All we've done is we've moved the decimal over here and made it 50. So we moved the decimal over here and made it 450. And this would move right there. It's so cool, y'all. Check this out. Watch. Okay, if we have 4, can we make a group of 50? No way. Okay, answer is no. You write a 0. If we have 45, can we make a group of 50? No, we don't have enough. So that's 0, right? Okay, so if we have 450, can we make groups of 50? Absolutely. So let's start counting. We have 5, 10, 15, 20, 25, 30, 35, 40, 45. Oh, here we go. And again, let's turn this into a rectangle. That's kind of funny. Okay, do you see what I did? I just counted by 5s and I put on another 0 just like I have over here. Okay, so it's just like this, but we have that extra 0. Counted by 5s, 50s, 50, 100, and so on. So look right here, we have 450. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 9. 50 times 9 is 450. 5 times 9 is 45, and we have that placeholder 0. Y'all, it has a relationship. Now again, why am I talking about this? Okay, I want you to pause and think about what you just wrote, and then I want you to watch this. Okay. If we have 50 4.3 divided by 3/10. Now this is craziness, right? That is a fraction. It's really actually still just division. Division, let's write it out. Okay, so 54 and 3/10 divided by 3/10. Okay, now just like what I just did in the previous problem, I moved the decimal over one place and one place so that it looks more natural, but they have the same value. If you move it over times 10, you'll get an equivalent value. So what does that mean over here? Watch this. I'm just going to move both of these decimals. If I move it here, okay, I have to move it here. If I move it one time here, I move a decimal one time here in our dividend. It makes it equivalent. It's so true. So watch this. Now, I'm going to think, okay, well, our decimal moved, but that doesn't mean everything has changed. We're going to have an answer with the same exact value as our original problem. It is very true. Okay, in our original problem, our decimals were here. We're just going to solve it a whole lot easier, forgetting all about that decimal at this time. Okay, this is where the decimal would land. We could go ahead and bring it up just in case we have a remainder. It'd be a decimal remainder, but that's okay. All right, so let's proceed as usual. If we have 5, can we divide that or make groups of 3? Yes, we can make 1. 3 times 1 is 3. So we take that out. We have 2 left. Bring down your 4. If you have 24, can you make groups of 3? Absolutely. You can make 8 exact groups of 3. 8 times 3 is 24. Take that out. That's what you were able to put into groups. And now we have exactly 3. So that would be 1. And then we'd have 0 remainder. So we didn't need any extra zeros here at the end. And that equals 181. So that is actually a correct answer. So what we can do is multiply that back and see if we get 181 times 3 and see if it equals 545. 43. Okay, so 1 times 3 is 3. That's 24 and 5. That's exactly right. Well, if we kept that decimal or whatnot, if we had that going on, oh no, actually we can't do that at all. Forget I said that. That's actually completely 100% correct. So if we had 54.3 divided by 3, that is the same thing, give you the same exact value as 543 divided by 3. All we did was create an equivalent problem where we changed, just like we changed, what if we had 4 tenths and we wanted to know what that value is? We changed it by increasing one place value position. Times 10 would be 40, times 10 would be 100, and those have the same value. 4 dimes have the same value as 40 hundredths. We're just using that same concept of increasing in value one place value position by multiplying by 10, moving that decimal over, and just dividing as usual. Let's practice some more, okay? Don't panic. All right, so let me think of another one. Okay, let's do 3,400, actually 340 and 55 hundredths divided by 1 and 5 tenths. Okay, let's see what happens. All right, now both of these, both our dividend and our divisor, are decimal values. All right, so what on earth do we do? Actually, hey guys, I love it when I make a mistake because that just validates to you that it's okay to make a mistake. Everybody does it. All right, so I just want to change this, take off that last 5. We're just going to leave this. I hope you wrote this down. Just erase the 5 in the hundredths place. We're going to do 340 and 5 tenths divided by 1 and 5 tenths. So let's think about this as a fraction. Okay, if we put 340 and 5 tenths as our numerator and 1 and 5 tenths as our denominator, which is another way to represent this division. It really is. It's always, fractions and division are the same. Remember, your denominator and your divisor are the same exact thing. They both tell you how many parts are in each whole group. I mean, isn't that true? So if we can move our decimal over by multiplying by 10 one time, okay, multiply by 10, to give us an equivalent fraction, all we have to do is the same thing when we're in a long division problem. So if you look first and see that you have a decimal divisor, all you have to do, if you have a decimal divisor, the first thing you do is move the decimal to the right to make it a whole number. Okay, if you do that though, you have to do the same thing to the dividend. So if you move it over one time to make it 15, then you have to move the decimal in the dividend over one time to make this 3,405. So the second thing you would do is move the decimal in the dividend the same number of times. Sorry, I'm running out of room here. Okay, so again, if you moved your decimal one time here, times 10, you're making 10 times the value, then you have to make this also 10 times the value, and that will create an equivalent problem. Absolutely true. Okay, so that's all there is to it. So here would be your new position for your decimal. It would come straight up. So if you had a remainder, You could still continue to add zeros as you need to, and then place your partial quotients just like we did before. It's literally just like you did before. No problemo. So let's figure this out. I'm going to use a different color. Let's do this pretty blue. Okay, so I'm going to start with this. I don't know if we're going to have a remainder or not, but let's find out. Okay, so if we have 3, can we make a group? Now remember, this is 15 now because we moved this decimal over. So we have 3, can we make a group of 15? No. Answer is no, you mark a 0. But 34, can you make groups of 15? Yes, you actually can make 2. If you think of clocks, 15 minutes and 15 minutes is half an hour, which is 30. 30 minutes. Okay. So 4 minus 0 is 4, and that's a 0, of course. So we bring down this 0. It's just dividing as usual. So if we have 40, can we make groups of 15? Yes, absolutely. We can still only make 2 because that's 30, and we'd have 10 left. Bring down your 5. All right, we're actually almost finished with this. This is really, really not so bad, is it? Okay, so this is a pretty large number. We have 15 going into 105. I'm going to start big. I'm going to go 15 times 9 because 9 is the largest number I could possibly put in this spot right here, right? So 5 times 9 is 45, and then 9, 10, 11, 12, 13. Oh, that's a little bit too big. So I'll back down a couple of groups here. Let's do 15 times 7 and see what happens. So 5 times 7 is 35. Oh my goodness, look at that. It's exactly what we're looking for. So 7 is our partial quotient we're looking for. That's exactly 105. And there you go. We have nothing left in our remainder. And we don't need to put anything here. It's our final quotient is 227. And y'all, that is absolutely correct. Okay, so let's review. What did we do? We looked at equivalent fractions. Fractions and division are the same. All right, they are exactly the same. So what you're going to do is if you need to get this decimal moved over so that you're not confused whatsoever, you're dividing now by a whole number. All you need to do is if you move your decimal over once, move your decimal over once in your dividend. That's what these notes say. First, move the decimal to the right, and that's in your divisor. Okay, where are we doing that? In the divisor. If you have a decimal divisor, what you're going to do is move it over and then move over the decimal in your dividend the same number of times. All right. Okay, we're going to do one more. Surprise, surprise. Okay. Let's see. While you take a deep breath, I'm going to do the same and come up with a really awesome problem. All right, I found the perfect problem. Okay, so what if we have 14 and 96 hundredths, and we're going to divide that by 46 hundredths. So now we're dividing by a 2-digit decimal value. So let's look at it again as a fraction, because remember, fractions and division are the same. This is a little wonky, but you literally do exactly the same thing as you do when you're finding equivalent fractions with tens numbers. So if you move this over twice, that would be like multiplying by 100, right? So if you multiply this decimal value by 100, you'll get an equivalent fraction, and you have a whole number down here. So let's do the exact same thing with these decimals. If you have a decimal divisor, all you have to do is move it over until it becomes a whole number, but count. This is 1, 2 spaces. So you take your dividend and move that decimal over 1, 2 spaces, and you're fine. It's just like making equivalent fractions like over here. All we did was move that decimal the same amount of times in both numbers. All right, so here we go. If you have 1, can you make a group of 46? No. Answer is no. You write a 0 because you have to have a partial quotient above each value in your dividend. Okay, if you have 14, can you make a group of 46? No way. That is not possible. You know what? Just to save some confusion, I'm going to take all that out. I've moved that decimal. Okay, there we go. If we have 14, can we make a group of 46? Absolutely not. Answer is no, you write a 0. So we haven't made any groups yet. But if you have 149, can you make groups of 46? Absolutely, but we're not sure how many. So I'm going to go ahead and just pick a number and say, all right, 46 times 3. Let's see if we're close to 149. So 6 times 3 is 18. That's 12, 13. Ooh, that's pretty close. If we're not sure, could we do 46 times 4? Absolutely. 6 times 4 is 24. That's 16, 17, 18. Whoa, that's way past. So that's not going to work. Let's use 3 right here. 46 times 3 is 138. Let's take that out. 9 minus 8 is 1. 4 minus 3 is 1. Of course, that's 0. So we have 11 left over. Let's bring down that 6. Okay. So if we have 116, can we make groups of 46? Absolutely, but 3 is too many. That's 138. So let's see what 46 times 2 is. That's 12, 8, 9. That's 92. That's going to work. So we have a 2. Subtract. So then let's see. We have 6 minus 2 is 4. And 11 minus 9 is 2. But uh-oh, we have a remainder. So we have to make a 0 here. We have to extend this. Does this 0 here change the value of what we already have? After this decimal, you can put as many zeros as you want to. Okay, so let's see. We have 0. All right, we're going to be bigger than this over here. So let's do 46 times 5. Let's see what happens. Here's 30. That's 23. Ooh, oh gosh, that was close. 230. Okay, so 230, that's 10. We've got 100. Uh-oh, we got to keep on going. Okay, so 46, that's going to be a 2. So it's 92. That would give us 80. We're just going to keep on going. So let's see, 46, that's only going to be 1. Oh gosh, 80 minus 46. Oh, good grief. 34. Okay, oh gosh, let's just keep on going. So that would be a 0. I hope that your paper, you'd be able to figure this out. This is kind of crazy. I'm having to make some scratch marks here because if I raise the screen, you're not going to be able to see the problem. Okay, let's do 46 times 9. Ooh, that's going to be too much. 46 times 8. Let's see what that is. Oh, Sophie. 24, that'd be 28. Well, yep, that's not going to work. 36. Oh, wait a minute. Oh, that'd be 41. Yep, that's just too much. Okay, what is going on? Hang on. Oh, 30. Oh, gosh, look what I did. See, these numbers are super far apart. Look, that's 32. That should be 36. What am I thinking? See, everybody makes mistakes. What did I just do? Oh, well, that's still too much. Okay, y'all, I'm just going to go ahead and stop there because I'm just messing this whole thing up now at this point because I just don't have enough room. Those are some limitations. We have some more values out here that we could just solve if we had unlimited paper. Okay, but 32 and 521 thousandths, I could round that. We could round it to the nearest hundredths place and say it's about 32 and 52 hundredths. We could always do that. All right, I'm going to pause the video. All right, so that last problem went kind of crazy because sometimes you could just keep on dividing forever and ever and ever. And until you find a remainder of 0, you just could potentially have, you could even have 15 decimal places until it finally zeroes out, or it may never zero out. So if you want to stick around and do one more problem, let's do that. And then I'm going to give you some practice problems so that you can try and work those. Or actually what I'll do is I'll post a tutorial video with just practice. Okay, and you don't have to do them, but I would suggest that you do, because the more you practice something, especially when something is new, the more you practice something, the better off you'll get. And it really is not so bad. It really, really isn't. All right, so let's do another practice problem. I'm just going to make something up, and whatever happens, happens. We're going to stop at the hundredths place, and let's just go from there. Let's do 542 and 9/10 divide. Oh, I'm going to do a tricky one. Let's see. Divided by 31, or let's do 31 hundredths. Okay, so check this out. The first thing we look at, first we look at the divisor, and we say, oh, we have a decimal divisor here, so we need to turn this and make this easy. We're going to move it over. We're going to make this 100 times its value by moving that decimal over 2 times. So if we do that here, we have to do that in the dividend as well, but we only have 1 decimal place value to move. That's not actually true. Remember, in 4th and 5th grade, when we multiply by 100, we can still do that. If we don't have a decimal place value, we make one. So we can do that. We can still move this over. All you have to do is fill in that space with a 0, and it changes this number to 54,290 divided by 31. So that's all you do. If you move this over twice, 100 times its value, you have to make this number 100 times its value, and you'll get the same answer. You really will. You could even put that in the calculator and find out if it's the exact same. Okay, I want you to work this out, but if you want to prove it to yourself that this works, if you multiply each value, both the dividend and the divisor, by the same number, then you will get an exact value. Okay, it's an equivalence that you can't deny. Okay, so I'm going to delete or erase some of these extra things to make it less confusing. Oh gosh, I need to put my 3 back. Okay, I need my 9 back. Oh my goodness, I'm deleting all the important stuff here. I need a 3 back and a 9. Okay. So here we go. Are you ready? And then here's our decimal. We don't know if we'll need a decimal or not. We could go ahead and we're going to go to 2 places for sure. So we could mark that down. Okay, if we have 5, can we make a group of 31? Absolutely not. We have not even close to enough. But if we have 54, can we make a group of 31? Absolutely, but only 1, because 2 groups would be at least 60. It'd be 62, wouldn't it? Okay, so we put 31 down here. That's what we were able to put into groups. So there's 23 with 2. If you want to go ahead and continue, I want you to do that. Pause this video, finish this out, and see if you get what I get. All right. Pause, pause, pause. When you come back, I'll work it through. Okay, so you should have 232. That's a lot of groups of 31. So I'm just going to start with 5. That's what I was telling my folks last year. Oh, not close. Let's try 31 times 7. Let's just skip because that was a pretty big jump, right? So 1 times 7 is 7. That's 21. Ooh, that's pretty close. I don't think I'm going to be able to fit another group of 32 in there, or 31. That'd have to be 100 or 201 in order for me to do that, and I've got more. So we're going to use 7. You could always multiply 31 times 7 or times 8 just to prove it, but it's not going to work. Okay, so 217. Let's subtract that out. Can't do that. That's a 5. That's 1. Okay, yeah, see, we only have 15 left. Okay, so 9. Oh, look, this is so close. We can use 5 there, and that's 155. That's only a difference of 4. Okay, bring down that 0. So 31 goes into 40 only one time. Ooh, I'm running out of room again. Okay, so I have 9. Oh, look, I'm going to have to go into my decimal place value. So 90. Oh, man, see, this is 31. If I have 3 groups of 30, that's 90. But look, I've got that 31 there. So it's going to have to be 2 groups. I know that for sure. So let's see, 31 times 2. We already talked about that would be 62. So here's what I'm going to do. I'm going to bring this 90 right up here so I can subtract that out and you can see it. That's just coming straight up here so you can see minus 62. Okay, so then I would bring that 0. If I was doing this down below, I would bring this 0 down there. 280. I'm going to try times 9. 1 times 9 is 9. Oh, look at this. That's 279. So a 9 would go great right there. That'd be 279 with just one little guy left over. So we would bring down another 0. And that's not going to go. Okay, 31 can't go into 10 ever. Okay, so here's where we can stop. We said that we wanted to divide to the hundredths place. Well, we can stop right here for our assignment purposes. If I know you can get that far, you are just fine. Okay, if this was right all the way across, then you are just fine and dandy. So on your assignment, if it says on there to divide to the hundredths place, if you start having to add zeros, you do not have to keep going. You just stop right there, okay? But these numbers all should be the exact same as mine. Okay, so I hope that's making a little sense. Remember, if you move your decimal from here 2 times over, then you have to move your decimal from here 2 times over to make that equivalent value. All right? Have fun!